So section 2.4, we're drawing quadratic graphs, and what we perhaps know already is if I have something y equals ax squared plus bx plus c, and that also might be f of x equals ax squared plus bx plus c, and then it might say draw the graph of y equals f of x. So those are the sort of notations that we get. If we have something like that, we're going to get either this shape or this shape, a U shape or an upside down U shape, or if you like, an N shape. They're called parabolas. The kind of U shape that we get here is a parabolic shape, it's a parabola. And you get this one if the coefficient of x squared is positive, you get this one if the coefficient of x squared is negative. If the coefficient of x squared is equal to 0, then you don't have a quadratic. That term would vanish and you'd have a linear term, okay? Now then, when we're drawing a quadratic, we need to be looking at a few main features of it, and this is really important throughout the rest of the book. You need to know, where does it cross the x-axis? To find out where any graph crosses the x-axis, put y equal to 0. Okay, so take the function, put y equal to 0, and solve the equation. And you might recognise that as it's finding the roots of the function. So the roots of the function, if you draw the function on an xy axis, the roots of the function are where the function crosses the x-axis. So when we've got a question asking us about roots of a function, we can do it algebraically, or other times they will give us a graph and say, from the diagram, identify the roots, and you need to know that you're looking at the x-axis crossing points. So put y equal to 0, that tells you where it crosses the x-axis, because of course on the x-axis the y-coordinates are 0. It crosses the y-axis when x equals 0, okay? So you put x equals 0 into the equation, and in that case, this case it would be y equals a times 0 plus, a times 0 squared, which is 0, plus b times 0 plus c, okay? So it crosses the y-axis when x equals 0, it crosses the x-axis when y equals 0, and that's something that, you know, if you're in my class, you know, I've made that point fairly strongly. Where does it cross the x-axis? Y equals 0. Where does it cross the y-axis? X equals 0. It's really important that you've got that in your head, and that's not just quadratics, that is any function you can be dealing with. X equals 0 crosses the y-axis. Y equals 0 crosses the x-axis. We have a parabolic shape. What we should say about parabolas, just as an aside, is if you take a point and a straight line, and you look at the locus of all the points which are equidistant from the point on the straight line, you get a parabolic curve. Okay, so that means everything on this. So if I pick a point on the curve here, the distance to the point is that, the shortest distance to the straight line is that, and if those two distances are equal for every point on the curve, then what I get is a parabola. Okay, so it's not just anything that sort of looks like a U, it has to follow this pattern. In terms of sketching it, that doesn't really matter. If you just draw a U-shape thing, then that will be fine. But strictly speaking, that's what a parabola is. And you might be interested to know that if you take an object and throw it through the air, that it follows a parabolic shape. And if you have a string, you know, if you have a fence post here and a fence post here, and you hang a wire or a string or a chain or something, then it has a parabolic curve. If you carry that curve on, it's a parabolic U shape as well. So we can be asked to find the coordinates of the turning point of the quadratic, and I dealt with that in a video. If you look on my channel, this video is in a playlist. The one just before it talks about finding maximum and minimum values of quadratics, and that is how we find the turning point as well. Because if you look at the turning point, if it's a upright quadratic, if it's a U shape, the turning point is at the bottom, and that's the minimum y value. And if it's the other way up, the maximum y value is the turning point. So we have, and I've done that in another video, using completing the square to find turning points of quadratics. So that is everything, actually. Oh, one more thing is that these parabolas are symmetrical as well. Okay, so that sometimes helps, and it's a sneaky little fact which often gets forgotten, but occasionally they come up with a question where they want you to use that. So a parabola is a symmetrical U shape. you might find that sort of oddly useful in various places. So sketching graphs, that's all there is to say.